So we will wait 1 or 2 minutes. Sure. So my last lecture, I started to discuss reciprocal lattice vectors. So we discussed some questions. Today also we will discuss some questions, and you have to do the question and send me the answers via WhatsApp. Okay. So the reciprocal lattice, sorry, the reciprocal lattice vectors that is three vectors a dash, b dash, c dash, that is equal to a dash equal to 2 pi into b cross c over a dot b cross c. B dash that is equal to 2 pi into c cross a over a dot b cross c. C dash 2 pi into a cross b over a dot b cross c. So in this way, uh, shall we do this question? A dash that is equal to a by 2 I plus j minus k. Did I do this question in the last lecture? Did I do this question in the last lecture? Students, did I do this question in the last lecture? Please tell me. I don't remember because I'm teaching for 2 batches. Yes, you did know. So, let's discuss. So this is the vectors. That means a dash a by 2 I plus j minus k. B dash a by 2 minus I plus j plus k. And c dash that is equal to a by 2 I minus j plus k. I minus j plus k. So, what you want to do? First, you need to find out the volume. To find out the volume, you need this one, determinant method. So you have to take a by 2, a by 2, a by 2. So a by 2 cube. Then you need to write down the vectors 1, 1, minus 1, 1, 1, minus 1, minus 1, 1, 1, minus 1, 1, 1, 1, minus 1, 1. Then you have to multiply. When you take this one, you have to remove these two, this row and this column, and then you need to multiply 1 into 1 minus 1 into 1. So similarly, you have to take a cube by 2. Similarly, this is your volume. So the same way you need to find out a dash, b dash, c dash. There you will get b dash cross c dash. So you need to do I, j, k vectors. Take the vectors and then find them. When you have to apply the reciprocal lattice vector formula, and then you will get these three vectors. So now please do this question. This is a very simple question. 5 minutes enough to do this question. Please send me the answer. The primitive translation vectors of a two-dimensional lattice are a is equal to 2i plus j, b is equal to 2j, c is equal to k. Determine the primitive translational vectors of its reciprocal lattice. So please do it and send me the answer. So here the three vectors are given. First, you need to find out the volume. So volume is 2i plus j plus k. So coefficient 2, 1, 0. Then 0, 2, 0, 0, 0, 1. So if you take plus 2, then at that time you have to cut down this, and 2 into 1, 2, minus 0 into 0, 0. Then you have to take minus 1. When you take minus 1, so at that time 0 minus 0. Then you are taking 0. So 0 into 0, altogether 0. So the volume is 4. Thereafter, you need to find out the reciprocal lattice vectors. First, you need to find out A dash. A dash, that is equal to 2 pi over V into B cross C. What is your B? 2J. What is your C? K. So you can take 2 out, 4 pi over 4 into J cross K. Here, I didn't use any determinant method because you have to multiply only two vectors. So it is very simple. So no need to go for the determinant method. You can go for the direct cross product method. I, J, K. This is your orientation. I cross J, that is equal to K. K cross I, that is equal to J. J cross K, that is equal to I. If the orientation is different, that means J cross I, then the direction is here in this way, and the direction of the vectors J cross I, that is equal to opposite. So that is why minus K. Similarly, I cross K minus J. K cross J minus I. So this method you can use. This is easy compared to the determinant method. You can use this method for the huge vectors, but you will get a large equation, large formula, and you have to multiply each and everything. So that's why for easy purpose, we are getting this determinant method to find out. But here you can directly find out. So J cross K, that is equal to I. So pi I, that is your A dash. Then second one, you need to find out B dash. B dash, that is equal to 2 pi over V into C cross A. What is C? K cross A 2I plus 2J. So you can expand this formula. 2 is a common K cross I plus K cross J. So K cross I is here. So the same direction, K cross I is equal to J. K cross I is equal to J. Then K cross J. K cross J is the opposite direction. No? K cross J, opposite direction. So you have to put minus I. Minus I. So 2J minus I. So B dash, that is equal to pi by 2 minus I plus 2J. Minus I plus 2J. Similarly, C dash, that is equal to A cross B. So 2I plus J cross 2J. So 2I plus 2I cross 2J. So 4 into I cross J. Here J cross J. So I cross J, that is equal to K. J cross J, the same vectors, when you multiply cross product same vectors, that is equal to 0. So the answer is 2 pi K. Do you have any doubt for this? Methods. I explained two methods. First method is that determinant method. By using the determinant method, the previous questions we used determinant method. But here in the last question, we use the vector method to find out the reciprocal lattice vectors. Both are you can use. You have to decide which method you want to use. If it is a large vectors, if it is a three more vectors, then determinant method is easy. And this case, this method is easy. No need to go for the determinant method. But if you use it, no problem. But for the time being, you can select which one is suitable. Do you understand? Do you all understand this method? Or should I need to repeat? Anything? Please talk.
Yes, madam.
Then we discussed this. Reciprocal lattice of FCC is BCC. We discussed this. And reciprocal lattice of simple cubic FCC and BCC. Here everything given. Now, can you do this question? The primitive translation vectors of FCC lattice is given by a by 2 I plus j, j plus k plus I. Please do this question. At least send me one answer. That means send me one reciprocal lattice vector. Find the volume quickly. Find the volume quickly and then find the answer. Next session. Have you found the volume? Anyone found the volume? It is a FCC vector. I think I discussed. No, we did not discuss. No. So it's an sum of you volume 0. No, my dear, you will not get 0 volume by 2. So please try this. Okay. So please try this question. I will share the notes via WhatsApp. This is the answer. This is a FCC vector. These three vectors are FCC vectors, and you will get BCC. If you find out the reciprocal of FCC, then you will get BCC vector. If you find out the reciprocal of BCC vector, then you will get the FCC vector. So this is the answer for it. Also, I have given another question here. It is little bit complicated question. It's a tetragonal vectors, tetragonal indium vectors. So please try this question as well as a homework. And I discussed more questions. So you have to try once again for that question to practice. And also you have to try these questions. Do you have any doubts with this section? Because I'm going to end this section and I'm going to start a new section. So do you have any doubts regarding related to this section? I think you are more clear. So I taught atomic packing fraction, crystal direction, crystal plans, crystal diffraction, reciprocal lattice vectors. So everything I taught to you. This is actually your course is one credit course, solid state physics, one credit course. For third year students, I am teaching 2 credit course, but the course contents of the third year and the second year are same, all the course contents. So your course contents is which is equal to 2 credit contents, but I'm going to cover this within 15 hours. Via the online mode, it is not a problem because I'm sharing the notes and you have to just understand everything. But when you come to the questions, I think I would like to omit some sections, but I will do continuous assessments. But now I will not tell which section I'm going to omit. At the last lecture, I will say which section I am going to omit for the final exam. So far, I did not decided yet, but some section I will omit for the final exam because the contents are 2 credit contents. So this one is so far at this point I'm completing 1 credit content and I'm going to start the second credit content. So that is all about material physics. Okay, so this is all about solid state physics. All are material physics, but this is condensed metaphysics, material physics, and we are going to study material physics. Okay. Can you see my screen, free electron theory?
Yes, madam.
Yeah, okay. So, we'll see. Free electron theory. Material physics, here we are going to study 3 theories. I mean, free electron theory, band theory, as well as Hall effect in semiconductors. So let me see what is free electron theory. Free electron theory means this theory explains the structure and the properties of the metals, properties of the materials, and also how the electrons, how the insulators not conducting the electrons, as well as how the other type of materials like metals, semiconductors conducting the electrons. So the reason behind the behavior of conductors, insulators, and semiconductors will be discussed mainly in this section. So that is why the scientists found free electron theory, because they wanted to identify what is the reason behind this conductivity change, conductivity variation. So that is why they developed free electron theory. So free electron theory has two parts. One is classical free electron theory. The other one is quantum free electron theory. First, we will study classical free electron theory. So the classical free electron theory is also known as Drude and Lorentz model. It's a macroscopic theory. In this theory, it obeys laws of classical mechanics. Laws of classical mechanics. They think that uh, they're taking this metal piece, and inside the metal piece you have atoms or molecules. So this is known as iron core. Iron core and random electrons. You have random electrons. So these positive ions are considered as a iron core, and these are considered as a free electron and random electron. And the important point is they assume that the electrons move in a constant potential. Electrons move in a constant potential. That is the assumption of free electron theory. Free electron theory can be useful to verify the Ohm's law, electrical and thermal conductivities, as well as optical properties of metal. But this theory failed to explain the reason behind the conductivity of semiconductors, insulators, and conductors. So that is the failure of free electron theory. This model is known as Drude and Lorentz model. The second thing is that quantum free electron theory. In quantum free electron theory, it is a microscopic theory. Classical free electron theory is a macroscopic theory. Quantum free electron theory is a microscopic theory. In this theory, the electrons in lattice move in a constant potential and obeys laws of quantum mechanics. The classical free electron theory obeys laws of classical mechanics. Here, it obeys laws of quantum mechanics. So that is the difference between quantum and classical free electron theory, but both are free electron theories. The scientist is Sommerfeld. Sommerfeld found this theory. The third one is band theory. This is a successful theory. The previous two theories are failure theories. They fail to explain the reason behind the conductivity of the materials. Band theory, interestingly, it explains in a beautiful manner how, why the conductivity changes in semiconductors, insulators, and conductors. So in this fascinating theory, it is assumed that electrons move in a periodic potential. See, periodic potential. That is the important point. The previous case, constant potential. Here the potential is periodic potential provided by periodicity of crystal lattice. Provided by periodicity of crystal lattice. It explores the mechanism of conductivity and semiconductivity in solid materials on the basis of energy band models. Energy bands. We will study what is energy band, how these bands will be created, and according to the band, how the electrons can pass through from one band to other band. Everything we will discuss in the later lectures. So this theory successfully explains the Ohm's law, electrical conductivity, thermal conductivity, but failed to explain heat capacity and paramagnetic susceptibility of conduction electron. This theory also failed to explain some parameters, but for this case, it is beautifully explaining the reason behind the conductivity. Quantum free electron theory. So quantum free electron theory is a theory. It's a Sommerfeld theory. In this theory, conduction electrons in a metal gas of conduction electrons in a metal as a gas of free electrons obeying Fermi-Dirac statistics. Do you know Fermi-Dirac statistics and Pauli exclusion principle? Did you study Fermi-Dirac statistics and Pauli exclusion principle? Okay. Yes, you have studied, no, under the section of, under the course of thermal and statistical physics. Okay, thank you, thank you. So, Pauli exclusion principle means no two particles can occupy the same quantum states. That means if you have one electron in a spin up, other electron should be spin down. This is possible, and the same quantum state not possible. That means same spin up or same spin down. That is not possible. That is the Pauli exclusion principle. Fermi-Dirac statistics, you can use only for the fermions. So electrons are fermions, so that you can use the Fermi-Dirac statistics. So here, the electrons freely moving inside this box. In this theory, each valence electron is taken to be free and movement of an electron is considered to be independent of all other electrons and nuclei. Valence electron, which is valence electron? For example, if you have a sodium atom, it contains electrons, no? Each shell, it contains electrons. So for the first shell, it contains 2 electrons, second shell, it contains 8 electrons, and the last shell, it contains 1 electron. So this electron is the valence electron because it is very much far away from the nucleus. It is easily escaped from the bonding from nucleus. So that electron is known as valence electron. So the valence electron is taken to be free and movement of an electron is considered to be independent of all other electrons and nuclei. This movement is independent. This electron is independent. So the potential energy of this electron is 0 and it has kinetic energy only. Sommerfeld investigated the behavior by applying the quantum theory, replacing the metal by potential energy box where the potential is taken as a constant inside. So, did you study quantum mechanics? Did you study quantum mechanics so far? Did you study quantum and atomic physics? Oh, okay. So you didn't study quantum and atomic physics, no, according to the new syllabus. So here there are 3 quantum mechanics concept. Here you have to study potential box, finite potential box. So inside the finite potential box, you have the electron. Here you have the electron. And Fermat's formula, have you heard about Schrodinger's equation? Anywhere? Have you heard about Schrodinger's equation anywhere? Have you heard about Schrodinger equations before? In chemistry, some students don't know Schrodinger equation. Okay. So I think I should teach. Okay. Okay. Thank you. Then only I can easily take the subject in a proper manner. So inside the box, you have electrons. So in the quantum mechanics, we are considered as a, this electron is a electron which is inside the box, and we can use the Schrodinger's equation. the wave function psi is attributed to each electron, and psi has been obtained as a solution of time-independent Schrodinger equation. So inside the box, you have electron. So in this electron is considered as a wave equation, and the solution of this wave equation can be identified by using the Schrodinger equation. This is the Schrodinger equation. Okay. This is the Schrodinger equation. There are two types of Schrodinger equation, one-dimensional Schrodinger equation and three-dimensional Schrodinger equation. Here we are considering the three-dimensional box. That's why here you want to use three-dimensional Schrodinger equation. So here this is H cross squared over 2m del 2 psi r equal to, plus V psi r, that is equal to E psi r, plus V psi r, that is equal to E psi r. Plus V psi r, that is equal to E psi r. This H cross, that is equal to H cross, that is known as reduced Planck constant, that is equal to H over 2 pi. H over 2 pi. And m is mass of the electron. V is equal to potential energy of the electron. And E is equal to total energy of the electron. Psi, this is equal to wave function. So you have to find out the solution, psi r. Okay, psi is the wave function of the electron. Here r is equal to, if you are going to use one dimensional, then you can directly use r. But here we are using three-dimensional box. That's why you are taking r is equal to xi plus yj plus zk. Okay, this is standard. Del is a standard formula. So del is equal to dabba over dabba x times I plus dabba over dabba y times j plus dabba over dabba z times k. This is the standard formula. Del squared is also given by this formula. Dabba 2 over dabba x squared plus dabba 2 over dabba y squared plus dabba 2 over dabba z squared. Since we are considering the three-dimensional box. Do you understand this? Okay, now we can move. If I start this proof, I need some time to complete, so that we have only 10 minutes. So I'm going to wind up at this point. In the next lecture, I will show some Schrodinger equation and the solution, so that you can easily understand. Thereafter, we can move further. And how about the continuous assessments? I think I should conduct one continuous assessment, one or two continuous assessments. Are you free during the period of social harmony? Are you all free during the period of social harmony? Why?